All right, we're going to be talking about arc length in this section, but before we go ahead and do our examples from section 4, I want to talk about two very important words and how they differ, because we really need to know what they are. And those are measure of an arc length, or measure of an arc, and the length of an arc. And a lot of kids don't realize that there's an actual difference between these two words, and so they get them confused. When we talk about the measure of an arc, so an arc in a circle, here we go, would be part of the circle. So here would be an arc of the circle. Oops, you can't really see that very well. So the measure of an arc is always comparing this arc to its central angle's measure. So central angle is going from the center of the circle, and it's going out like this. Okay, so this measure of the central angle would be the measure of its intercepted arc. So if this measure of this intercepted circle is, I don't know, let's say 50 degrees, then the measure of this intercepted arc would also be 50 degrees. So the units that we're talking about when we're talking about the measure of an arc is always in degrees. I don't care how big my circle is or how small my circle is. The measure is always going to be in degrees, so it doesn't matter. It's always just in comparison to what the angle is. So the bigger the measure, the bigger the central angle. The smaller the measure, the smaller the central angle. When we talk about the length of an arc, we are talking about the actual physical length if I were to measure it with a ruler. So that's talking about part of the circle's circumference. Or the perimeter of the circle. And our units in that case is always going to be centimeters or inches or miles or whatever units that we're given. So measure is just how does it relate to the central angle? How much of the circle does it take up? It's always in degrees, so 0 to 360 degrees. Doesn't matter how big or small the circle is. The length is actually the physical distance that we are measuring, okay? So let's go ahead and start with a couple of example problems from section 4. An arc length is part of the circumference, and there's a simple, when we have more simple problems, we'll start off with some simple problems, simple numbers. To find a simple arc length, we're just going to use simple fractions, okay? So for example, in this circle, circle A, I'm trying to find this arc length. So the length of BC, so basically I want to find the length of this arc from that point to that point. And I want to find the actual length of it, if I were to measure that with a ruler or whatever. Find the arc length. Well, the length of BC of this is 9 inches. Okay, so 9 inches. Well, since we're trying to figure out arc length, I really need to know what the entire perimeter is. So I'm going to figure out the perimeter, or I should say the circumference, because that's the perimeter of a circle. So let's change that to C. Circumference is 2 pi r. I know that, or I could say pi times the diameter, since I have the diameter in this case, which is pi times 9, or 9 pi. That is the circumference of the entire circle. Well, in this case, I know that I have my arc length is half, right? It's a semicircle. So, well, in this case, I'm just going to take half of 9 pi. So the arc length of BC, which would look like that, is going to be 9 pi, and I'm just going to take half of it. Boom. And I could just leave my answer like this, 9 pi divided by 2. That's my exact answer, and that would be in inches. Or I could approximate it. Let's go to the nearest hundredth, and I'm going to hit 9 times pi divided by 2, and that is approximately 14.14 inches. So that's just using some basic easy fraction. Example 2, find the arc length of AB. So I'm trying to find this distance here. Okay, again, Arc length is dealing with the entire circumference. So I'm going to start by finding the entire circumference of the circle. My radius is 12. So 2 pi r, that equals 2 pi times the radius. My entire circumference is 24 pi. Okay. Well, if I think about what part 45 degrees is out of all the degrees in a circle. 45, well, I know that another 45 would make 90. Another 90, another 90, 1, 2, 3, 4, 5, 6. That's really an eighth. This is an eighth of the entire measure of a circle. So that means that this arc length is going to be 1/8 of the entire circumference. So what is 1/8 of 24 pi? I'm just going to take 24 pi and divide it by 8. That gives me 3 pi. Ooh, that was easy. And that's my exact. And I don't know my units here, so I would just write 3 pi units. If I want to give my approximate, 3 pi is 9.42. 9.42 units. So that's my approximate there. I'm going to box these because I like it when I have my answers boxed. All right, let's go over example 3. Find the length of arc GH. So I'm looking at this length right here. Again, length is talking about the entire circumference, so I'm going to find the entire circumference of my circle. 2 pi r is 2 pi, my radius is 11. I'm looking at 22 pi is the entire circumference. Now let's going to take a look. My central angle is 120. I know all of the angles equals 360. So if that's 120, this is 120, this is 120. I know that this angle is 1/3 of the entire circle, which means that this arc is 1/3 of the entire circumference. So I'm going to take 22 pi and divide it by 3 because that's 1/3. I really can't simplify that at all. My units is yards. So my exact would be 22 pi over 3 yards. That's the length. And approximate, that's a pretty bad approximate sign. 22 pi divided by 3. Approximately 23.04 yards long is arc GH. All right, let's do example 4. Here we go. We have, oh, I don't think that C copied well. This is triangle ABC. I know it's a right angle, and I know that AC is the diameter. Okay, I know that AB is 12, so I'm going to label this. BC is 5. Find the length of AC. 5, 12, unsure. Well, I know something about Pythagorean triples. I know that this is going to be a Pythagorean triple just because I'm familiar with them. But if I didn't know, first of all, I need to know the radius in order to figure this out because I want to find arc AC. I want to find this length right here, which is half of the circle, I know. So I have to figure out the circumference of the whole circle. I need to figure out either the radius or the diameter, which is the hypotenuse of my triangle. So if I don't know this particular Pythagorean triple, I just use the Pythagorean theorem. So I'm going to do 5 squared plus 12 squared equals my hypotenuse squared. I'm going to call my hypotenuse x squared just for fun. So 5 squared is 25, 12 squared is 144, x squared is just x squared. 25 plus 144 is 169 equals x squared. I'm looking for a number times itself that will equal 169. I'm going to take the square root, and I know that the square root of 69 is 13. 13 times 13 equals 169. That means that this entire hypotenuse is 13. I can use this to find the perimeter or the circumference of my entire circle. So now circumference equals, since I already have diameter, I'm going to use the pi d formula, equals pi times 13, or 13 pi. So my entire circumference is 13 pi around. I'm looking for the measure, or the length of arc AC, which is half of it. So AC equals 13 pi, half of that. I'm just going to leave my answer as 13 pi over 2. That's my exact answer. What is it, centimeters? And approximately, I'm going to say 13 pi divided by 2. That's approximately 20.42 centimeters. There we go. So when we're finding the arc length, if we have nice, easy answers, like our what we're comparing, our angle is a nice fraction of the whole, you can just find the entire circumference and then figure out what fraction of it you're dealing with. That works for nice numbers. However, not everything is nice numbers. So if you turn your page, we'll continue, and we are going to find the way to find any arc length, nice numbers or numbers that are not so nice. To find any arc length, we want to set up a proportion. This is, and I've seen a lot of different formulas out there. Just use this formula and you can memorize it. But I found generally that kids who just memorize the formula eventually forget the formula because we don't use it a lot. But this right here, if you learn to set up a proportion, a proportion is super easy to set up. So here's what you're gonna do, arc length. The arc length over your total circumference is going to equal the central angle over your total angles. So what you're really comparing is your part to your whole. Part to whole equals part to whole. Part to whole equals part to whole. So let's go ahead and go through this, this example, and then we'll do example 5. So in this example, we have a circle. I know that the central angle is 100 degrees. That's not really a nice angle in comparison to 360. I know my radius is 7, so I want to find this arc length right here, the measure of that. So I'm going to set up my proportion. Arc length over the entire circumference, so part over whole, is going to equal my central angle over the entire amount of angles in my circle, which is 360. Okay, so step 1 is write out your kind of general proportion. Part over whole equals part over whole. Now I'm going to fill in what I know. I don't know the arc length, but I do know the circumference of my entire circle. Okay, and you might have to do a little bit of work on the side. Circumference equals 2 pi r, which equals 2 pi times 7, which equals 14 pi. So you might have to do a little bit of extra work. The entire circumference is 14 pi. My central angle is 100 degrees, and there are 360 degrees in a circle total. Okay, so now I have arc length, which I could call, if I wanted to rewrite this a little bit bigger, I could call this x over 14 pi equals 100 over 360. So that's kind of what it would look like more simplified. I'm going to cross multiply, and that's where I get the 360 times x equals 14 pi times 100 is 14 pi. So cross multiply, and then you're going to solve for x. So in this case, I would divide both sides by 360. That's where we get this 1400 pi over 360. I could simplify my exact answer, just simplify 1400 over 360 as a fraction, but rounded to the nearest hundredth would be 12.22 centimeters. And this is just a reminder that you are going to use the fact that the circumference is 2 pi r. So round and remember your units if necessary. Okay, so general steps, write out your general proportion, part to whole, fill in what you know. You're going to cross multiply, and then you're going to solve, and then you're going to round if you need to, and remember your units. So let's do example number 5. We want to find the length of arc ST, so this length right here. I know I'm going to be dealing with length, so I'm just going to start right away to find my circumference. Circumference 2 pi r, radius is 6, so 2 pi times 6 is 12 pi. Fabulous. Now I'm going to set up my proportion. I'm going to call, I could say ST if I wanted to. I could say arc ST. I could call it X, whatever. The length of ST over the entire length, the entire circumference, my entire circumference is 12 pi, is going to be the same value as my degrees of my central angle, which is 50, over my entire angles in my entire circle, which is 360. So part over whole equals part over whole. Now I'm going to cross multiply. I have 360 times the arc length of ST equals 12 pi times 50. And I really don't feel like figuring out what 12 times 50 is. I think it's 60 something, 600. There we go. My brain is tired. So 600 pi equals 360 times that arc length. Again, if you don't like using XST, then just put X there. You can do that too. It doesn't matter. I'm going to divide by 360. Arc length equals 600 pi over 360. This is my exact value. Now, if I wanted to keep my exact value, but obviously I want to simplify it, I would just start simplifying it. I'm going to divide by 10 tens. 60 over 36, I can divide by 6 sixths, and I would get 10 pi over 6. I could still divide by 2 twos, and that equals 5 pi over 3. So that would be my exact value, and my units is yards. And then if I just wanted to go ahead and give my approximate value, when I'm doing my approximate value, I'm going to go ahead and use my original amount because that way if I made a really dumb mistake in simplifying, I'm not using my mistaken value, I'm using my original value. So that's just kind of a good rule of thumb. So 600 pi divided by 360 is approximately 5.235, so 24 yards. So there is the length of arc ST. Your goal is you want to be able to use proportions to find the arc length. And again, if you can just remember part over whole equals part over whole, you will be good to go, especially for the next section.